Folks, here's your chance to practice reading route maps. Just like you practiced reading prefix lists to become better with prefix lists, you need to practice your route maps to become better with those route maps. So as we look at this example here, we can see that we have a route map called redis-rip, so redistribute rip, applied to OSPF. So we are controlling the rip routes that are redistributed into the OSPF process. So I want you to take a moment, capture this, take a screenshot, pause me, do whatever you need to do to take the time to go through this. And I'd like you to create sentences as to what these particular route maps and their sequences will accomplish. So give it a try. And when I come back, we will go through them together. Hopefully you've had a chance to go through these route maps and come up with sentences that explain each and every single one of them. And if you were able to do that, then you can perfectly read a route map. But for those of you who had trouble, follow along with me. We have this route map called redistribute rip that has been applied to the OSPF routing process to control those rip routes that are being redistributed into OSPF. So what is the route map comprised of? Well, first of all, we can see here that we have the very first sequence number of 10 for that particular route map. It is a permit sequence, which means we will be performing redistribution on those routes that match the match criteria. And in addition to that, I see some set statements that are going to modify the default behavior of those routes that are being redistributed. So in this example, we can see that it says match the IP addresses that are in access control list 23 or 29. That's big. That's big. You see what I said there? Or, not and, or. Because they're on the exact same line, the two access control lists in the match criteria, they are represented as ORs. So match access list 23 or access list 29. You don't have to match both. And so what does access list 23 state? Access list 23 is stating we are permitting 10.1.0.0 through 10.1.255.255. And access list 29 says 172.16.1.0 through 172.16.1.255. So any route that matches those two ranges doesn't have to be both, because it wouldn't, right? It's either a 10.1 something or 172.16 1 dot something. It can't be both at the exact same time. So definitely the OR logic makes sense in this particular case. If you match either of those two, then you will have a metric set to 500 when redistribution occurs, and you will have a metric type set to E1. The default metric type is E2, and the default metric is 20 when we redistribute into OSPF. So let's come up with our English sentence. Here's what it is. Sequence number 10 is going to redistribute those routes that match access control list 22 or 29, and when they are redistributed, they will have a metric set to 500 and a metric type set to E1. Now, your sentence may have not been exactly like mine, but were you at least close? Were you able to pick out the components here and the values of this sequence? Hopefully you were. If not, give it a try again. Let's go to sequence number 20. Sequence number 20 is a deny, which means that we will not redistribute those routes that match the IP address in access control list 37. So I've pretty much given the sentence, haven't I? Sequence number 20 states do not redistribute any route that matches access control list or the IP addresses in access control list 37. And what is that, by the way? It is 10.0.0.0 through 10.255.255.255. Hold on a second here. Folks, does this address range here fall within this address range here? Yes, it does. Yes, it does. Access control list 37 is 10.0.0.0 through 10.255.255.255. 10.1.0.0 through 10.1.255.255 falls within that range. Isn't this a conflict of interest here? Will this really work? Yes, this is going to work perfectly fine, exactly as we envision it to work. And here's why. Top-down processing, immediate execution upon a match. Think about that. Up here, we have our permit statement. So we will redistribute those routes in this range. That is processed first. Then this is processed, and anything outside of that range gets denied, meaning not redistributed. So that's why the order of operations is important here, and we understand how the flow works. So this works perfectly. However, what about everything else? Maybe there's some other routes that we want to redistribute as well. Let's look at the sequence number 30. Sequence number 30 says redistribute everything that matches the match condition. And I don't see a match condition, so what does that mean? I want you to yell it out loud. If you do not see a match condition, folks, in a sequence for a route map, what does it mean? Yell it out. That's right. It means match everything. So sequence number 30 is our catch-all route map here, saying that if you don't match sequence number 10, you don't match sequence number 20, then you will be redistributed. And when you are redistributed, you will end up with a metric type of 5,000, or pardon me, a metric of 5,000, and you will have a metric type of E2. But we don't have to specify the metric type of E2. Why? Because that's the default. If we did not specify this, it would still be E2 no matter what. But they're showing you that you can put it in there if you want to. So folks, how well did you do? How well did you do coming up with your statements? If you struggled, go over this again as many times as you need to until you understand the process of reading the route maps. And practice them. Write some out on paper. Give yourself some sample scenarios and try to figure out, all right, if I wanted to accomplish this, filter this, or change this, or modify that, how would I go about doing that? How could I create a route map to accomplish that? And remember, it's not just access control lists. No. You can use prefix lists as well. Prefix lists that give you control over the subnet mask as well during that redistribution process, not just the range of IP addresses. So practice, folks. Practice reading route maps. It is very important for your success.